So welcome to this session. First, I know I'm the last session of the day, and you had a very, very tough day. So I hope that you will enjoy that session. And I will try to watch you. If you see you sleeping, I will try to wake you up, because it's kind of boring for me to see you sleeping. So how are you today? Well, that's a small one. Again, how are you today? Good. Much perfect. All right. Are you ready for some war? All right, we're going to talk about this service mesh war, the new hope for Kubernetes, and I thought that the best way of presenting different service mesh in the CNCF landscape competing themselves in the market was to use the Star Wars themes. So it's going to be in the far, far galaxy. We have different CNCF service mesh, if you look at the CNCF landscape, all of providing the feature of service mesh. But as a user, the question is, which solution should I use? And I'm going to try to answer that question today by providing some numbers, and then, of course, you will decide from your end. So let me introduce myself briefly. My name is Henrik. I'm a cloud-native advocate working at Dynatrace now a bit more than 4 years, involving in the amazing cloud-native ecosystem, observability world, and I've been now a CNCF ambassador since more than a year. And prior to that, I spent my entire career as a performance engineer, meaning that I like to test, break, tune, having fun. That's basically, I think, the performance engineering practice is an amazing practice because you discover so many architecture, you tune them, you configure them. So if you want to learn different architecture pattern, go for it. It's just amazing practice. So that's why I'm still producing some content on a YouTube channel called Perf Bytes on the bottom. You have the QR code. So now I can say that I produce less often because I have less time on that. And since 4 years, I decided to open a YouTube channel dedicated to observability in general called Is It Observable? So if you want to see if it's observable, check it out on YouTube. The QR code is up there. All right, enough of speaking myself. Let's start. So a long time ago in the far, far galaxy, a couple of CNCF projects were competing themselves. And to be able to answer this question, I went to the quest of comparing those service meshes. So I have run a lot of tests, to be honest. And I can guarantee that none of the Gorilla boats or cubes or any of them has been harmed. They were handled the load pretty well. This talk is not here to blame any of those projects. In the opposite, I share my feedback to the project. I'm a big fan of all of those CNCF projects, to be honest. And the intention is more about give you some insights, so then you can choose the best solutions for your project and for your need. So let me introduce the different clang. So it's not ordered by the age of the project, but it's more about who is the various clang. So we have Kuma. Kuma is a open source service mesh provided by the Kong, the company doing the gateway APIs. Then we have Linkerd, supported by Buoyant. There you will see that the open source support is kind of weird at the moment. We have Cilium. So Cilium, he's not a real clan, you will see. Is it a real service mesh? We're going to try to answer that question today. We have, of course, the wise and the oldest Jedi of the service mesh world, which is not Yoda, but Istio. And then we have his Padawan that is released a few years back. Now we have the version 1 that is exciting, called Ambient Mesh. So this is going to be the various clang that we were going to compare today during the sessions. So there is a new hope in the galaxy. I don't know if you've been aware of that. The new hope here is intended to help us to avoid having different journey of configuring those service meshes, and I'm referring to the gateway API. So how many of you have heard about the gateway API and are currently using it? 2 hands, 3, 4, okay. So let me just remind. So gateway API, if you have been using networking in Kubernetes, you have Ingress. And Ingress, when you define your Ingress in the same CRDs, you will define the security options plus the routing selection. So basically, it's 2 different people configuring this. There's the actual platform guy who says, oh, I want to use SSL, blah, blah. And the other guy will say, hey, that's my project. I want to route it to that services. And that was the problem, so they decided to split the configuration into various CRDs. You have the gateway, so this is going to be everything about security, which port will be exposed. And then you have the routing itself, so if I need to be routing to my service, I will create an HTTP route, or gRPC route, TLS route, whatever you need, depending on the protocol that your application is using. So that's the purpose of the Gateway API. And there is an initiative started a few years ago called the Gamma initiatives. And Gamma, I don't know what the name Gamma, but it's for service mesh. So it's basically Gateway API configuration for service meshes. And there's a new also version called Gateway Interference that is specially designed for holding any AI agents, of course, because the HTTP connections are different, so they have also a specific support for that. Similar to the Ingress controllers, there's no implementation. So you have the CRDs, that's great, but you need actual provider, something that will do the routing, and that is going to be defined through the gateway class. And of course, you can use Istio or Nginx or Traffic. There is plenty of different providers out there. But that sounds super promising. But there is a problem. Yes, there's a big problem. As of now, for Ingress, it's pretty cool. It works pretty well. For service meshes, it's getting better, but it's not super documented. And you will see. I try to do my best with Gateway APIs in this benchmark. And you see that for some specific use cases, you have to go back to the traditional CRDs of the service mesh. So what are we going to touch base in this session? So first, we are going to touch base of what do we expect in terms of feature in a service mesh. Then we're going to compare the service mesh in 3 different angles. The first one is the design experience. I'm going to also look at their documentations and the complexity of each of solutions. Then we're going to look at the component required for that, and it's going to be general in every solution. In fact, we will start with this one. And then we're going to cover the observability, because, of course, service mesh provide a lot of extra telemetry data in top of the platform. And of course, the most important piece is going to be the benchmark. You want number, you will have the number. So stay awake until the end, otherwise you will lose the most important piece, which is the numbers. All right, are you ready? Yes. Oh, I am so boring. Am I boring or? Gosh, I need energy here. So let's start with the actual components. So in a service mesh, for those who've never been using it, let's remind, you have 2 different things. You have the control plane. So this is pretty much a language that you know in Kubernetes. And you have the data plane. So control plane is basically every CRDs, every configuration that you're going to apply in your cluster would be handled by the control plane, and the control plane will apply it to the cluster. And then everything that is related to networking, routing, or anything is going to be part of the data plane. So the data plane is going to be your app plus proxies. And I say proxies with an S because you can have 1 or maybe more proxies depending on which solution you're using. And all those solutions, on top of providing some networking capabilities, they will also emit naturally logs, of course, metrics, and traces. Then in the design pattern in this world, you have 2 family. The family is going to be sidecar model. We can say that's the old way of doing things. And then you have the new model, which is sidecar-less. So when Istio started their adventure, they wanted to provide something that helps you to provide all the networking layer for your microservices without having to touch your code. And at that time, there was no major technical solutions, so they had to go through sidecar, meaning that your workload will be mutated, and we will add in your pod an extra container with a proxy, and that proxy will be in charge of all the networking rules that you may have defined. So meaning that if you have a sidecar model, your workload needs to be restarted. Otherwise, this proxy will never be injected in your pods. So it's pretty efficient. It's pretty also performant in a way that your pod is talking to local hosts, so very efficient. So that's great. And all other thing is that the downsides of that is that if you have thousands of pods, I mean you have thousands of proxy, each of them will consume memory and CPU, so at the end you consume more resources in your cluster. The sidecar-less model, meaning that you don't need a sidecar anymore. You don't need to restart your app. You will have a proxy somewhere, probably in the node, usually. that will be in charge of doing the routing. And usually this type of proxy, which is on the node level, will handle all the layer 4, meaning TCP, UDP communications. And then if you need a layer 7, so HTTP, gRPC, you will need to add an extra proxy that will be there for these specific roles. So this is the differences. And if you look at this, the various clang that we discussed, Kuma is a sidecar model. They rely on Envoy, but it's not a real Envoy. It's modified versions of Envoy for Kuma. Then you have Linkerd using their own proxy. It's also a sidecar model. It's called the proxy is called simply Linkerd proxy. No surprise. Cilium, they don't have any proxies, and if you want to do any Envoy, layer 7, they will rely on Envoy. Istio, Envoy, of course, and last Ambient, they use two proxy, the Z tunnel, we'll discuss about this later, on the layer 4 for TCP, UDP, and then Envoy for layer 7. Now, let's look at what type of forces we expect from those service meshes. When I define microservices, there are a couple of features from the networking side that I need. The first one, of course, is Ingress. I need to expose my app outside of the world. I want to have egress, which communication will be going out. Then I want to have, of course, encryption, so mutual TLS. So I don't want to have the handle that on the code. I want to have something managing my TLS certificates and doing some rotations. If I'm a service A, I need to discuss to service B. If service B is not responding, I want to have probably a retry logic in place. So this is the type of policy I want to implement. I want to have traffic split. So for those who never heard about traffic split, if you do canary releases with version 1 and version 2, I want to have 20% on version 2, 80% on version 1, and this is possible with service mesh in a very easy way through traffic split. Circuit breaker is a way of detecting unhealthy nodes and then letting know the load balancer that this pod won't take any traffic anymore. Rate limiting, I set a threshold, let's say 100 requests per second. If I reach that threshold, then I will throw a HTTP error code to the upstream. So then my app is protected. Same thing with timeout. If my service is too slow, and I can put a timeout, and then I will generate an error. So those are typically the features that we expect when we deal with service meshes. So what are the solutions supporting those? Well, you'll see that surprisingly, all the sidecar model service mesh supports all the features that we need, except of Linkerd, who doesn't have the Ingress. It's designed, they don't want to do Ingress. So if you want to do Ingress, you will have to install your own Ingress controller for that need. Cilium and Ambient, you can see they have no support for circuit breaker, timeout, and retry logic, and rate limiting. I heard recently that through the Envoy operator, so there's a new component, it seems possible. So I will have to retry, but for now, I didn't have the chance to be successful on those policies. Now, in terms of design, service mesh is great, but sounds a bit scary when you've never been dealing with networking. And that's true. So let's cover the experience when dealing with those products. So starting with Kuma. Kuma, which is kind of be surprising when you install it, you look at the CRDs deployed, you have tons of CRDs, and you say, oh, okay, why do I need so much CRDs? But the true story behind it's to make the experience simpler. You have one CRD per policies. I want to have mesh rate limiting. I want to do rate limiting. I will go for mesh rate limit. I want to do timeout. I'm going to go for mesh timeout. So simple like this. No complexity at all. It supports pretty well the Gateway API, at least for most of the features. But for most of the configuration, you will use their own CRDs. And the CRDs configuration is quite very simple. You don't need to be an expert in networking. It's going to be very easy. To add your app in the data plane, nothing complex. You take the namespace where your app is hosted. You add annotation, Kuma sidecar injection enabled, and voila, your apps will be in the part of the data plane. You can do it also on the deployment if you need, or a stateful set, but it's very simple. Linkerd, here it's a different story. So Linkerd supports the gateway API for routing, traffic split, circuit breakers. So most of the policies of the service mesh supported so far from the gateway API. But when it comes to rate limiting or other policies, you will have to use their own settings. And it's quite overcomplicated. You have to define a server for which endpoints exposed, the routing exposed. They have specific policies for rate limiting as well, TLS authentication. So TLS is not enabled by default. You will have to enable it by yourself. So I would say the configuration is a bit more complex compared to the others. And that's why they have this CLI. It's called Linkerd. I mean, no surprise. And then from that CLI, it will help you to configure the actual server CRD, for example. And if you want to add your apps in the data plane, they don't have annotations on a namespace. You will have to add on each individual deployment one by one. That's why you use Linkerd inject, and that will basically modify your YAML files, and then you can apply them. Cilium use eBPF, as we know, because this is a CNI, very powerful CNI, to increase the network performance. They have also, so it's not related to service mesh. They have extended the network policies of Kubernetes with Cilium network policies, where you can do a lot of layer 7 configurations, very powerful and very easy to use. And then they have a support for gateway API, but only on the CRD supported so far. So it's just very limited. And if you want to use any layer 7 policies, you will have to use the Envoy config. That is quite complex, to be honest, and is very specific to Cilium itself. Istio, well, Istio is out there. It's follow the progress of the gateway API. So with the latest and greatest gateway API, you have the Istio support by default. So you have you can use HTTP route for many network policies. You can do otherwise. They have the old traditional CRD, which is destination rule, virtual services, service entry, and more. So they are a bit complicated, to be honest. But once you have invested in you pass the learning curve, it's quite easy. To add the actual proxy, similar to Kuma. You can do it on the workload level, or you can do it on the namespace level. You just need to add just a simple annotation, and that's it. Ambient is the big brother of Istio. And to be just a small comment about Ambient, the idea of Istio, what they wanted to provide to the market, where you can deal the networking layer without any modification, Ambient is doing this. So if you've been using Istio and you want to use Ambient, it's the same CRDs. It's the same components. You don't have to learn anything else. It's the same thing. And the way it works is that you have a Z-tunnel. So it's going to be a daemon set. So every node of your cluster will have a Z-tunnel. And Z-tunnel will be responsible for TCP, UDP communications of your data plane. And then if you want to do any layer 7, like I want to rate limit, or I want to do some request timeout on my pods, I will rely on a waypoint proxy. So you can deploy it on a namespace, or you're free to deploy your waypoint proxy in a very easy way. To use it, it's going to be similar to the others. You use annotations, so you can have data plane mode ambient, so you enable ambient mesh in your namespace. And then if you have a specific workload that needs to use that waypoint proxy because it's rely on layer 7, you can say, oh, I'm going to use a specific waypoint proxy, and here it's going to be hotel demo waypoint, the name of the waypoint that you deployed. So at the end, I would say that from a design perspective, because I started with Istio, I suffer a lot, and then I get used to suffer. So now I think the documentation is pretty much better than it was in the past, to be honest. Amazing now, I can say. Ambient as well. And in terms of design, it do what you would expect. Ambient mesh, the downside is just that it doesn't have all the policies that I was expecting. That's why I did a small note about it. Linkerd documentation, it is what it is. It does the job, but it's overcomplicated from my perspective. It could have been simpler, but that's my feeling. Cilium, I don't know for you, but every time I go to a Cilium website, I feel stupid. I feel that I didn't do any studies. It's probably a network engineer that built the documentation, and that's why maybe I feel that way. So Cilium, I think it's a great product, but the documentation is like horrible. So if you want to use Cilium for service mesh, prepare yourself. Prepare yourself. In terms of feature coverage, I can say that it's not really there. And by the way, I think that Cilium is not a service mesh. Cilium is complementary to a service mesh, but it's not a service mesh. Observability. That's one of the key features that we expect from a service mesh. I install it. I want to have details about what's going on the network. Who is calling? The latency, the error codes, everything on the network needs to be visible. And all of those service mesh provides that. And well, we are in 2026, meaning that I want to have an OpenTelemetry support. I don't want to scrape metrics anymore. I want to get the data, use a collector, and we don't talk about complex scrape configs or whatever. So Kuma is supporting OpenTelemetry pretty well. And similar to the design experience, they have a mesh metric, a mesh trace, and a mesh access log. OK, no problem. So on the data plane, it supports OpenTelemetry pretty well. And on the control plane, and you will see that it's true for most of the solutions, they only expose metrics. And logs, of course, because you're always emitting logs. So if you want to have the health of your control plane, you will have to scrape the metrics from the control plane. Like I said, this supports on the data plane, they support everything on OpenTelemetry, so you can deploy it, and you will have, if you don't have instrumented your code and you will just figure out where you're spending time in terms of latency, use a service mesh. It will provide you the traces of your app just with the proxies, and then you can figure out, oh, that component is slow. And then you can start instrumenting to figure out where it's slow and which method if you want. Linkerd. So Linkerd has, by the way, they have also a UI, Kuma. I think it's great when you start configuring your policies, so you can see if it's been accepted, the problems related to your policies. So that is helpful, by the way. But you see that everyone is providing this. Linkerd has an extension called Linkerd Wiz that provides observability and plus the visibility of your mesh. They have a partial support for OpenTelemetry, so they have traces that is supported. Don't look at the docs, because the doc says no. But if you go and dig in the tutorials, we'll see that, yes, they support it. Logs is not supporting on OpenTelemetry, so you have to collect them manually. Metrics is still on Prometheus, so you'll have to scrape them. And the control plane also exposes metrics through Prometheus. Cilium use a project called Humble. It's an amazing solution for network monitoring at the TCP level. It's just insane. But it doesn't expose anything. You need to use Humble UI. So if you want to get, of course, you can expose metrics and logs, but the level of details that you have on the UI is completely different from what you get from the metrics side. Istio and ambient mesh, there is different way of configuring it. So you have a mesh config that defines how you want to set up your mesh in Istio. And in the mesh, you have this notion of providers. You can set a provider for logs, a provider for metrics, a provider for traces. And this is where you're going to configure, oh, here is my endpoint, OpenTelemetry collector, for example. And then you can also set up by default that everyone is going to emit their metrics and traces there. Or you can also customize and say, on that namespace, I will deploy a telemetry object, and I want to send that data elsewhere. So this gives you some extra configuration layer. The control plane has the others. It's only emitting Prometheus metrics, so you'll have to scrape them. And also, similar to the others, they also have another project called Kiali that give you a lot of details about the mesh. They give you the service graph. It's pretty amazing, to be honest. But otherwise, yeah, they have a strong support on OpenTelemetry in general in ambient mesh and Istio. And by the way, if you're using ambient mesh and you want to do some tracing, you need a waypoint proxy because it's going to be a layer 7 feature. So as a result, I would say ambient and Istio and Kuma, straightforward, very simple. And you turn on, put in an endpoint, boom, voila, you get your data. No surprise. Linkerd and Cilium, there is some processing to do. You have some homework to get the details that you want in your backend of your choice. Now let's cover the performance. Performance for this, I wanted to measure a few things. So I said, OK, we are adding proxy everywhere. Does it really introduce latency? So what I'm going to share as a number is not the latency at the pod or at the service level. Here I'm taking some microservices architecture that has 12 to 15 microservices, and I'm measuring the latency introduced with all the calls, meaning that all the proxy involved in those 11 microservices, and then I'm reporting that as a difference. So the idea is that I'm a user and an end user interacting on a website. Do I have a difference if I have an app with service mesh or without service mesh? That's the first thing I want you to figure out. Does it really add response times? And the second thing that I want to add is, what about resources? How much resources will that eat in my cluster? So let's try to answer those questions. So how did I achieve this? Well, no surprise, you need to test. So you can use ChatGPT or anything else. It won't generate those numbers. You will have to do a lot of tests and stay focused. So first, I need to do a test, the baseline. So no agent, no mesh installed, nothing in a cluster, just to get the reference of terms of response times. Then I clean up the cluster, I install Kong, and I include my application in the mesh. I measure the response times, and then I decided to add policies, the same policies on each solutions. I selected rate limiting and request timeout. So I did Kong with policies. I get the numbers, and then I do Linkerd, just with the mesh. And then I do Linkerd with the policies Cilium, but remember, they don't support request timeout and rate limiting, so no policies installed. Istio with the policy, and ambient without policy, because it doesn't support those policies. By the way, there's a QR code here, so if you're on a Saturday and it's raining, it's very cold outside, and you say, oh, what should I do today? Then go to the GitHub repo, clone it, install it, and have fun. It's going to be an amazing day. You're probably going to need 2 days for that, to be honest. All right, so what do we have in that cluster? We'll have a couple of things. I will have the actual mesh. Of course, you need a mesh. I selected 3 demo applications. So we have the open telemetry demo, including 12 to 13 microservices available in the open telemetry repo. Then I have the hipster shop. For those who never heard about it, it's the old microservices demo built by Google. Then we have Easy Trade. That's the Dynatrace demo that we've built. And we have the default namespace with 2 collectors, one for the logs, daemon set, and stateful set will be responsible for metrics and traces. And then I have the Dynatrace operator that will be in charge of reporting the actual resource usage of those components. All right, so let's start with the constant load. Yeah, I did 2 tests. Constant load, 30 minutes of test with 50 users on each single application. So there's a load test behind. And then I did a load test, so stress test, where I add 50 users every 30 minutes. So it's a 2-hour test on each for each solutions. Let's start with the latency. I can see that you have a lot of from far away. I think it's a lot of colors. It's like a painting, I guess, for you. But for me, it's clear. So start in the top. It's the latency, the response times of the front end, of the front application of each application. And then I compared. So Cilium provides 0 latency, so no differences between agent and Cilium. Ambient mesh, Linkerd is 2.55 milliseconds added in top of the app. And then you have ambient mesh with 3.69, Kuma 5.59, and last we have Istio with 6.43. So you can see that at least you have already the number 1 champion is Cilium, and then Linkerd and ambient mesh, Kuma and Istio. It's funny to see that we have a proxy model that is a sidecar model that is second. I didn't expect that, to be honest, when I saw the results. Then in terms of control plane, so on the left, it's the memory usage, and on the right, it's the CPU usage. Linkerd is eating a lot of memory. And then so it's about 700 megs of consumptions. And then on the far end, it's the first one is close to the old ones. Is the blue one is Cilium. I don't see the color. Yeah, it's Cilium. And then you have the CPU. CPU is still Linkerd, very expensive. And then Kuma and Istio is quite close. And then if you look at the actual proxies, so it's the sum of all the proxies. It's not one proxy. You don't expect 1 gigs per proxy. It's all the proxy, including that cluster. So of course, we can expect that sidecar model is expensive, which is true. But surprisingly, Linkerd is almost the same level as ambient mesh. I didn't expect that, to be honest. And then on the memory side, it's Istio, and then Linkerd and Kuma is fighting, and then you have the other ones. Now, if I apply load test without policies, we get pretty much the similar score that we had. So Cilium has added a small portion of latency on top of that. And then you can see that we have ambient close to Cilium, to Linkerd, second position. And then we have Kuma and last Istio. And then in terms of resource consumptions, it's going to be the same thing, I would say, except that you can see that Kuma suddenly, in terms of CPU of the control plane, is behaving weirdly. So is it the telemetry data, the traces? I don't know. But yeah, that was. And then if you look at the agents, it's the same behavior in the memory consumptions. And then if you look at the proxy usage on CPU, now you can see that Kuma, which is the red one, is following the load. Same thing for Istio, no surprise. And then Linkerd is very close to ambient mesh. So same conclusion, but you can see that Kuma, for some reason, started to increase in terms of resource consumptions. Now let's apply the policies. So what is the result? So remember Cilium and ambient mesh, no policies, so the same numbers. And here you can see that Linkerd, 2.55, again, I'm surprised. And then Kuma is about a few microseconds added, so we have 6 instead of 779. And last we have Istio with 9 milliseconds. And then if you look at the resource consumption, same conclusion. Kuma still have those spikes in the CPU. In the memory of the proxy, same thing, is still Kuma and then Istio. And then we have on the proxy side, same thing, Kuma and Istio is the most heaviest one. Now if we apply the load test on these similar settings, we can see that Cilium is 1.17. And then, again, Linkerd, same number as ambient mesh. And then we have Kuma and last Istio. And no major conclusion, except that Istio started to consume more than Kuma. In the previous graph, it was Kuma that was in the load test that was consuming more resources. But here's Istio and then Kuma, and then again, Cilium and ambient mesh fighting to each other. So in terms of resource consumptions, what can we get out of these observations? The first thing is Istio and Kuma, sidecar model, of course, they are expensive and they provide more latency than expected. Envoy, I didn't expect that. I didn't expect that one sidecar model will have the same numbers as a sidecar-less model, which is ambient. But remember, Linkerd is only handling TCP and HTTP. HTTP and gRPC. It doesn't care about UDP, it doesn't care about TCP, which in the opposite, Kuma and Istio is doing more. So behind the scene, that's why those proxies may be more heavier, because they have more networking rules to be handled. In terms of control plane, we saw that Linkerd is the most heaviest control plane that we have in terms of memory and CPU. And otherwise, I would say that Cilium is surprising. But again, keep in mind it was just Cilium without any policies. Is it just doing CNI? The question is yes. The answer is yes. I'm using Cilium as a CNI, nothing else. So, because remember, there's no way of adding a data plane. So whatever is in the cluster will go through Cilium. So you have no choice. You cannot pick and choose who you want in Cilium or not. But here, ambient is promising because it's doing TCP and UDP, and it's doing tracing, it's doing everything that we expect. So in terms of conclusion, to go to that conclusion, I did different families of ranking, and I applied some score based on the observations. I would say that if you want a sidecar-less model that is easy to configure, provides the latest and greatest features, go for ambient. I mean, ambient is, with the number of maintainers behind it, it's an amazing project. So that's what I think. I'm not a big fan of Linkerd because of the design and also the way they're managing the projects from my own perspective. But that's my opinion. But I was super surprised by the performance, to be honest. So if you're just doing HTTP and gRPC communication, I mean, Linkerd could be a super good option. So, and then Istio, it has created this bubble, this buzz around service mesh a couple of years ago. So it's still a good solution, but again, look at the numbers. It's the most heaviest proxy. It's the most unperformant in terms of response times. Remember, it adds more latency than the others. But I will keep, from my perspective, ambient or Linkerd. Or if you've never touched any service mesh and you're afraid about it, go for Kuma. Kuma is amazing. It's super simple to configure. And last piece, you are just already revealed that Cilium is not a service mesh. It's a network CNI. It's super efficient. So if I want to use Cilium, I will combine it with a service mesh because it makes sense. I will have the Cilium network policies. I will have some extra enforcements on the network. So it's not about Cilium against the other. It's more about, oh, I may want to use ambient with Cilium. I would more go for that options than pretending that Cilium is a service mesh. If you want to have more details on each of those solutions, I have created episodes on the YouTube channel for Kuma, Linkerd, Istio, Ambient Mesh, Gateway API. I didn't expose that benchmark, but I should. So maybe I could take some time and reveal those in a video. And otherwise, what I would say is I would do at KubeCon North America another type of benchmark like this, but more focused on the Gateway API to figure out, deep dive, if each of those service mesh can be configurable using the latest and greatest that has been released a few months back, and see if we have the support that we need for the Gateway API. All right, and by the way, consume the videos. They are for free. If you like it, like it. If you hate it, but let me know, so then I can improve the content. Otherwise, you have no bad feedback, you cannot improve your content. So I need bad feedback for sure. But don't be too aggressive on YouTube, please. All right, so thanks. And if you have any questions, I'll be very excited to hear about your questions.